everyone. So in this video, I'm going to give you a general overlook of matrix multiplication. Before I do that, uh, we need to revert back to dimensions. So basically, recall that the dimension of a matrix A. So I have dimension of a matrix A is equal to rows by columns, right? Rows by columns, and this is standard for any matrix, any linear algebra course, any exam that you sit for. The dimension of matrix will always be rows by columns. The thing is, the only time you can perform matrix multiplication, so let's say I have some matrix A and I have some another matrix B, right? The only time I can multiply these two matrices together, so basically A, B, would be when the columns of the first matrix equal the rows of the second one. So basically what I mean by that is, let's say A is a n by m matrix. What this basically means that A is some matrix that has n rows and m columns. Now, I want to multiply that matrix with B. Then B must have dimensions of m by something. Okay? Now, it's not as simple as I'm just going to reverse the rows and columns right here. So the dimension of B would be m by n. Well, it could be n. It doesn't not have to be n, but generally it's just any number. But the main important thing is that um, the number of columns of the A matrix must equal the number of rows in the B matrix. And then the dimension of the resulting matrix, which would be AB, would be the outer two. So the dimension of the outer matrix multiplication would be n by something. Okay? Now, I haven't actually done matrix multiplication. I'll do it in this video so you'll get the hang of it. But, so I'll review it again. Okay? So let's say I have some matrix n by m, and I'm trying to multiply it with another matrix. That matrix must have m rows. Okay, that's the first thing. M by something. Let's say k. Okay, k could be equal to n, or k could be just another number. So the way you check is the inside two must be the same. In this case, they are. So I can proceed with matrix multiplication. And then the outer two would be the dimension of my new matrix in that order. So the dimension of that matrix would be n by k. Okay, so now I'll actually use this property to figure out the product of two matrices, and I'll just do that now. So let's say for this example, we have that I don't know. We'll start off simple. So let's say A is equal to 1, 1, 2, 3, and B is equal to 2, 1, 2, 2, 3, 2. Well, first of all, let's figure out, can I multiply these two matrices together? Well, the dimension of matrix A is 2 by 2. What's the dimension of matrix B? 3 by 2. Well, can I multiply them? No, because the inside two, which is basically the 2 here and the 3 there, are not the same. So I cannot multiply them, right? So if this is the case, then A by B is equal to does not exist. It doesn't exist. Okay, I cannot multiply them. Now, what if I have, I don't know, I'm just going to get rid of the last row down there. What's my new dimension? Okay, the dimension of the first one is still the same, 2 by 2. Dimension of the second one is also 2 by 2. Are the inside two numbers the same? Yeah, they're all 2's. And what will be the resulting dimension of my new matrix? Well, it'll be the outside 2, so it's the 2 over here and then 2 over here. So it'll be 2 by 2. So how do I actually calculate them? This is where everything's been leading up to now. So A times B is equal to... There's a couple different ways you can multiply matrices. I'm just going to show you one method because I don't want to confuse you. And if I show you multiple methods, then I'll probably get confused by myself. So what you do is that for the first element, you take the first row of the A matrix, and then you do the dot product of it with the first column of the second matrix, B. So basically, 1 times 2, so 1 times 2, plus 1 times 2, right? And then, for the second element, you do the same thing. You take the first column, or sorry, the first row of the A matrix, do the dot product of it with the second column of the second matrix, which is the B matrix. So again, it'll be 1 times 1. I'm just going to put it over here so I don't run out of room. So 1 times 1 plus 1 over here times 2. Right? Now, you do it in different color over here, so it makes sense. For the second row, the elements in the second row, what I'm going to do is I'm going to take the last row, which will be second row in the first matrix, perform the dot product of it with the first column. Okay, so 2 times 2, 2 times 2, plus 3 times 2. Right? And then, for the last element, I'm going to take the last row, the second row in the A matrix, perform the dot product of it with the second column in the B matrix. So it'll be 2 times 1 plus 3 times 2. Right? And then you simplify that, so AB is equal to, what is it? 1 times 2 is 2, and then 1 times 2 is 2, so 2 plus 2 is 4. 1 over here, and then 2 over here, so that's 3. And then 4 plus 6 is 10, and 2 plus 6 is 8. Alright, so A times B is equal to this matrix 4, 3, 10, 8. Let's do another example. Okay, so for this example, it probably will get a little messy, so I'm going to have like a large matrix over here, but it is important that you do realize how to handle large matrix multiplication. And basically, if you're able to do this, then matrix multiplication will become second nature to you. You'll be able to do well on most things relating to matrix multiplication. So let's see, can I multiply these two matrices together? Dimension of the first one is 3 by 3, right? 3 rows, 3 columns. What's the dimension of the next one? As 3 rows, and then how many columns? 1, 2, 3, 4. Right? So yeah, the inside two numbers are the same, so I can go on with matrix multiplication. What will be the dimension of my next matrix, the resulting one? It will be 3 by 4, the outside two numbers, right? So matrix AB will be 3 by 4. So let's see, I'll take the first row, right, and dot product that with my first column. So I'll get negative 1 times 0, 0, 0 times 0, 0, 0 times 0, 0. That was quick. For a second element, I'll take the first row, dot product it with the second column. So negative 1 times 1 is negative 1, plus 0 times 2 is 0, 0 times 3 is 0, so that's just negative 1. And then I'll dot product it with the third row, or third column, so negative 1 times 4 is negative 4, and then the rest of them will just be 0, so it'll be negative 4. Lastly, the last column, right, so negative 1 times 7 is negative 7, and then 0 times 8 plus 0 times 9, which will be just 0, so this is just negative 7. Okay, so far so good. Now, for the next one, actually I'm just gonna change this matrix up a little bit. I don't want to deal with messy numbers. I think you get the hang of it, right? So I'm just gonna change this to 0 and 1. Okay, doesn't really make a difference. You know the idea. So for the second column or second row, right, I'll take the second column of my first matrix and do the corresponding dot products. So dot product it with the first column, so there will be 0 times 0, which is 0, plus 1 times 0 is 0, 2 times 0 is 0, so this will just be 0. Then do it with the second column, 0 times 1 is 0, plus 2, plus 6. this will be 8. And then dot product it with this column, so 4 times 0, 0, plus 5 plus 12, right, so 17. And then the last column, so you get 7 times 0, 0, plus 8 plus 18, so 26, right? And then lastly, I'm going to use a different color, stick it out, basically. So 1 times 0, 0, 0 times 0, 0, 1 times 0, 0, so this will be 0. 1 times 1 is 1, 0 times 2 is 0, and then plus 3, so 1 plus 3 is 4. Now lastly, these two columns, so 4 plus 0 plus 6, so 10, 1 plus 7, or it's not 1 plus 7, sorry, 1 times 7, so 7 plus 0 plus 9, 16. Okay, so that's it. That's basically, you know, not the most annoying matrix multiplication you'll see, but because the numbers were easy, but it doesn't matter if the numbers are decimals or fractions or whatever. It's basically the same concept. You take the first row of the first matrix, first column of the second matrix, do the dot product, you'll get the first element, and then you just apply that same algorithm kind of thing with for every other element. There's a couple of different ways you can do matrix multiplication, but I feel like this is one of the most simplest ways, so I don't want to confuse you by showing you different ways. And for most purposes, this method will work. Now, important things to notice is for numerical operations, right? We have a plus b is equal to b plus a, right? So in normal just numerical multiplication, if a was 2 and b is 3, so 2 times 3 is 6, and b times a is also 3 times 2, which is 6, I'll get the same answer. But in matrix world, a times b is not the same thing as b times a. The reason for that is because if you switch out the b and a over here, you probably won't even be able to multiply them because sometimes the dimensions don't match up. And sometimes, even if the dimensions do match up, you may not be able to get the same answer because you're doing different types of dot products, different values with the dot product. So, yeah, it doesn't make sense. So that's it for this video. Hope you liked it. Hope you learned a lot. And good luck, and I'll see you in the next one.